Hi guys, today we're going to learn about systems of linear, quadratic, and quadratic equations. So, we need to remember what is the equation of the circle in the standard form. So you know that you have x minus h squared plus y minus k squared is equal to the radius squared. You know that hk is the center of the circle and r is going to be the radius. So what we have in this equation, you see that you need to write a system of equations to represent each graph. We need to use this graph to solve each system. Okay, so for number A, what I see, the first thing that it strikes me is the circle. So this circle, it seems that it's centered at the origin, okay? So you do know that basically what you have here is x minus 0 squared plus y minus 0 squared. And you know that the radius in this situation, I count 1, 2, 3, 4, 5. 5 squared is going to be what? Well, this one, you know that this is going to be x squared plus y squared, and this is going to be equal to 25, and that's the equation of the circle that you see here. Secondly, you see a beautiful line here. So what we have is that if we do rise over run, if we take this one first, you know that that point is the intersection, and that point, well, we have that point. We have also this point that it's more important. You see that this point is the y-intercept, and I know that the y-intercept of that situation is going to be 0, negative 5. In addition, I do know that the slope of this line that you see over here is going to be it's going to be 3. Why? Because you are rising 3 and you are running 1. So I run 1, rise 3, so my slope is going to be 3. I know that it's positive because this one is increasing. Therefore, my second equation is going to be y is equal to 3x minus 5. So your system is going to be this equation and the circle equation. So this is going to be your system of equations. Okay? Clearly, the solution that you can see here, okay, if we are using the graph, you know that it's going to be the intersection over here and over here. So the solution is going to be basically the point over here. You have that it's the point 3, 4, right? This is the point that we have here, and the point that we have over here is going to be the point 0, negative 5. And then I just do my squiggly lines as usual, and that's going to be your solution. For part B, you have a similar situation, okay? But here the circle is not centered at the origin. Okay, so what you see is that this circle is centered at negative 3 and positive 1. Okay, so this is going to be the center. You see that that's the center of your circle. Okay, so we know that the center is going to be negative 3, positive 1. You do know that the radius is 1, 2, 3, 4. Okay, so you know that the radius is 4. Therefore, your equation of the circle is going to be x plus 3 squared plus y minus 1 squared is going to be equal to 16. Okay. Now in this situation, you know that the linear equation that you have over there, we know that the slope is going to be negative 1 because you see that it's I'm basically falling 1 and running 1, so you have that it's negative 1 your slope, so it's going to be negative x. And then you can see that the y-intercept is here, the point 0, 2, so you have that it's plus 2, so this is your system of equations. Okay, so now you're going to tell me, what is my solution? My solution of this situation is going to be the intersection of both equations. The intersection is happening here and here. I don't need to do any algebra, I can just look. Okay, and that point that we have here at the top, the first point that you have, is going to be negative 3, 5. Okay, so negative 3 and 5, and this point that you have over here is going to be positive 1 and positive 1. Okay, so those are going to be your solutions for this situation. So for example number 2, what we're going to do here is you need to again solve each system algebraically. You have a circle here and you have a linear equation. As you can see, this is a quadratic equation and this is a linear equation. Okay, so what we're going to do is, since I have y equals negative x plus 2, what I'm going to do is I'm going to plug this one inside the quadratic equation. Okay, so I have that x plus 3 squared plus, and then I'm going to substitute all of that instead of the y, so I have negative x plus 2 minus 1, and then you have square equals 16. So this guy replaces the y over here. Okay, so I'm using substitution. Okay, so from here I'm going to basically combine like terms inside the parentheses. So what you have in this situation is pretty much negative x plus 1 squared is equal to 16. Okay, at this point I have no option but to actually expand both quadratic expressions that I have here inside my equation. So I have that the first one is going to be x squared plus 9 x plus plus 6x plus 9, and this is going to be plus x squared, okay, minus 2x plus 1, and that's going to be equal to 16. Okay, so after that we're going to combine like terms. Okay, so you have the quadratics here. Okay, so you have 2x squared, then we have the linear, that one, this one. Okay, so you have that it's going to be plus 4x, and last but not least you have the constants here, here, and this one. Okay, I'm going to move it to the other side. So this is a 10 minus 16, that's a negative 6, and this is going to be equal to x. At this point you are like, okay, so I can see the greatest common factor, that it's 2. Okay, so you have a situation like this. You equalize it to 0, you pass it to the other side. So technically what we are solving here is x, okay, we factor. Okay, so what you are solving here is x plus 3 equals 0 and x minus 1 equals 0. So you can see that here you have that x is going to be equal to negative 3 and x is going to be equal to 1. Okay, so as in the previous class, what you're going to do is you substitute the negative 3 in this one, and you have that it's positive. Okay, so you have that your point is going to be negative 3. Okay, and it's going to be comma 5. Okay, then we substitute the 1. I would plug it here, so you have negative 1 plus 2, so you have that that's the beautiful number 1. Okay, so these are your two solutions. Okay, so let's move on to part B. So for part B, what we have again is kind of like a circle. It's not kind of, it's a circle, and then you have a linear equation. Therefore what we have here is we have my quadratic equation, and then we have my linear equation. I need to clean up the linear equation, and I would clean it up as x equals 1 minus y. I'm going to plug this equation here instead of the x. So what I would have here is I would have parentheses 1 minus y squared, then you would have plus y is equal to 4. After that you need to expand this equation, having 1 minus 2y plus y squared equals 4. After this you need to combine like terms. So you see that these two are like terms, so I would have 2y squared minus 2y, and then I move the 4 to the other side, so you have negative 3 is equal to 0. So at this point you can recognize that we have no option but to use the quadratic formula. If you use the quadratic formula here, you have that y is going to be equal to negative b, so this is a, this is b, and this is c. So that's going to be 2 plus minus the square root of negative 2 squared minus 4 times a times c. Okay, so this is going to be your formula, 2 times a, 2 times 2. So when you combine the inside, your discriminant is 4 plus 24, which is 28, divided by 4. Okay, so you do have that y is going to be equal to 2 plus minus, and you know that 28 is 4 times 7, so it's going to be 2 root 7, okay, divided by 4, and we can simplify this as 1 plus minus root 7 divided by 2. Okay, So you do have that your y is equal to plus minus y is equal to plus minus root 7 divided by 2. Now we have to get my x as well, right? So I'm going to use this one for the x, okay? So when I plug it in, what do you have? Well, you have that x is equal to 1 minus y. So you can tell me pretty much, you can tell me that x is equal with the plus. I know that it's going to be 1 minus, and you have all this equation, so you have minus, and you're going to use a parenthesis, 1 plus root 7 divided by 2. So what do you have here? Well, you do have, when you combine like terms, that this is a 2 over 2, okay, if you want to see it with all the details, okay? So you have that you distribute this one here, and then all of this has the 2. Okay, so you can combine this one with this one, so you do have that this is going to be what? 1 minus root 7 divided by 2. And then when I substitute the other x, this is x1, my x2 is going to be 1 minus, and you know that it's 1 minus root 7 divided by 2. Okay, so this is going to be equal. If you want to see it in another way, don't worry. Okay, so you know that it's 2 minus 1 plus root 7, everything divided by 2, and this is going to be equal to 1 plus root 7 divided by 2. So your two solutions are going to be the following. The one with the plus, the first one that we have here, is 1 plus root 7 divided by 2, comma, and that one we had that it was 1 minus root 7 divided by 2, okay? The second one that we have, that it's this one, okay? So your basically this is your x, this is the y, this is the x, okay? And the y, what was the y for this one? It was 1 plus root 7 divided by 2, okay? And that's for part B. For part C, what you have is you have two quadratic equations. So you have this quadratic and this quadratic. So the good thing here is that you have them cleaned up, so you have y equals something and y equals something. So what we're going to do here is you are going to set them equal. So you have x plus 3 squared plus 2 is equal to negative x plus 2 squared and plus 3. What you are going to do here is pretty much very similar to the first examples. You are going to expand both situations, okay? So on this side, you would have that this is going to be x squared plus 6x plus 9 plus 2. On the other side, you are going to have that this is going to be negative x squared plus, you have that that one is going to be 4x plus 4 plus 3. You distribute the negative that you have at the front here, this one, okay? So you have negative x squared minus 4x minus 4 plus 3, okay? After that, we're going to combine all the like terms, okay? So you have your quadratic, so you have that that is going to be 2x, and I'm going to move them here because you know that I like my leading coefficient being positive, okay? After that, I move my linear term, so I only have those two, so I move this one positive, so this becomes a 10x. Then we have the constant term, so I have a bunch. Okay, so this one is pretty much an 11, and this one I see it as a negative 1, but it's moving to the other side positive, so you have plus 12 is equal to 0. Okay, so after that you are like, okay, so I do have greatest common factor, so you have 2x squared plus 5x plus 6 is equal to 0. After that, what you have is you can factor the situation. Okay, so you have that it's x plus 2 times x plus 3, and this is equal to 0. So pretty much your x's are going to be x equals negative 3 and x equals negative 2. Okay, so pretty similar to the previous one, you need to substitute the x in one of the others. So let's do negative 3. Okay, if we plug negative 3 here, you know that this is a 0, so you get a 2. Okay, if we plug negative 2, I would plug it here because it becomes a 0, so you know that negative 2, it would be 3, and those are your solutions. So for part D, what you have is you have a circle, okay, center at 0 with radius square root of 5, and then over here you have a parabola. So what I want to do here is you could recognize that it's a quadratic and a quadratic. Immediately as I see it, I'm like, I'm going to replace it here, but honestly, square square, that's going to be a little bit problematic. So what I highly recommend you to do is manipulate this equation as negative 2x squared plus y equals 0, and then the other one I can multiply it times 2. So if you multiply this times 2, you have 2x squared plus 2y squared is equal to 10. So here you can clearly see that we have an elimination situation. Okay, so if I do elimination here, okay, and I'm going to do my result, you cancel that one. What you have left there is you're going to have 2y squared plus y is going to be equal to 10. Okay, so from that I'm going to pass the 10 to the other side, so you have 2y squared plus y minus 10 is equal to 0. So at this point you can factor out. Okay, you can factor out however you want, master product method immediately. Okay, so you have that it's 2y plus 5 times x minus 2 is equal to 0. And after that, you can recognize that your two y's are y equals negative 5 over 2 and y equals 2. Okay, so that's the 2 that we have. Now, when we plug this one, okay, we plug this one here. Okay, so what you have, okay, so I'm going to do it separately so you can see the situation. For this one, what you have is negative 5 over 2 is equal to 2x squared. Remember that in this situation you need to solve for x. So what we're going to do here is I'm going to have negative 5 over 4 is equal to x squared. And you are all happy, like ready to, square root both sides. But you are like, you know what? This is not possible in the real number plane, okay? So this is not a real solution, okay? So you know that that's not possible. So we do it for y equals 2. For y equals 2, what you have is y is going to be equal to 2x squared. You know that that's going to be a 1x squared, which is possible. Okay, so you know that your x is going to be equal to plus minus 1. Okay, so your two solutions, okay, the negative 1, when you plug the negative 1 as the x, you had that it was 2. Okay, and when you had the positive 1, we had that the y, it was 2 as well. So this is going to be these are going to be your two solutions for part D. So let's look at example 3, okay, and see what's the deal with example 3. So we need to write a system of equations to represent each solution. We don't need to solve, okay? So what we have is the range in miles of a broadcast signal of a radio tower is bounded by a radius of 40 miles, okay? So this one, it seems like a circle, okay? So since you don't have information about the circle, and honestly you want to do it the easiest way, the circle should be, okay, center at 0, and then since the radius is 40 squared is going to be 1600. So you have that part. The table shows that the horizontal x and the vertical y, okay, distances the car is from the radio tower in miles. We need to write a system of equations that models this situation. So what we can see is that this must be the other equation. Let's see what happens. Here you see that the change that you have is 2, 2, 2. The change that we have here, so the change here is pretty consistent. Let's see the change. Here you have that the change that we have is negative 1, negative 1, okay, and then by the way, this is not 2, this is 4. And this we don't care because that one is different because they skipped the 2. Okay, so what you have is a linear situation, so this one, forget about it. Okay, so what do you have here? You have that basically your rate or your slope is negative 1 over 2. Okay, so you have that y is equal to negative 1 over 2x plus b, which is your y-intercept. but you do have the y-intercept over there, so you have that it's plus 30, okay, and this is your system of equations. Now for part B, we have another idea. Let's read it together. So you have that a small child runs straight through the circular path of a sprinkle in a game to avoid getting wet. The path of the sprinkler has a radius 5 feet from its head. What we have here is more information, okay, but it seems that the quadratic ended. If the child first enters the path of the circle at a point of 3 feet from the west and 4 feet from the south of the sprinkler head, and exits the path 4 feet from the west and 3 from the north of the sprinkler head, what system of equations would model the paths of the child and the sprinkler? So what we have here is, first you have a circle, okay, which is the radius of the sprinkler system. Okay, so set your sprinkler system at 0. Okay, the radius 5, it tells you that it's going to be 25, okay, here in the equation. Okay, another thing that you do have, they gave you basically pretty much, they gave you 2 points. Here they are telling you that 3 to the west. The west is on the left side. So what we have is that this kid entered in -3, and for south is -4. And the other point that they are giving you, okay, so 4 feet west again is -4, and then 3 feet north, that's +3. So they are giving you 2 points, okay? So pretty much what you have is a circle, and this is a linear equation. So what I would do is I would get my slope. My slope, remember, it's y2 minus y1, so y2 minus y1 divided by x2 minus x1, okay? So what you have here, we have that this is going to be equal to 7 divided by -1, which you know that it's -7, okay? After that, you have, well, you can substitute a point, any that you want, okay? If you want to do this one, I don't know, because it's negative, I don't know. So you have that one is going to be equal to 7 times x plus 4, okay? You distribute the 7, combine like terms, so you have that y is equal to -7x minus 25, so your system of equations is this one, and y equals -7x minus 25, and that's pretty much it for this problem. I hope you find this video helpful. Bye!